What's up, everybody? Welcome to this episode of Let's Make. This is a video series where I more or less do a live stream of making a simple game or remaking a simple game. So you can kind of see at least my process, or if you're new to game dev, the process of developing a game. And today I thought we'd get a start at least on making Flappy Bird. And if you missed the craze that was Flappy Bird, this is it. So it's a very simple game. You just have a bird and just gotta click the button, or it used to be on an iPhone. So you would tap the screen, and if you don't tap, the bird falls, and the idea is just to get through these pipes. Now, I am quite terrible at this game. I rarely get through more than a couple of pipes. This was very popular, so much so that I think actually the developer somewhat hated the attention that he ended up getting almost overnight. So I thought we'd remake this. I don't know what Flappy Bird was made in, but I thought we'd remake this in Unity and see whether we can add some flair or do something unique to it. So that's our point of reference. So far, I've just started with a 3D game. I always start with a 3D game. I never really start with 2D. If I want 2D later, I can just always go back to it. So I always start with the 3D game. No rendering pipelines or anything like that. We won't need it. And I just got this free asset from Cinity Studios. It's called Simple Sky, just a sky dome. In fact, I'll add that to our scene right now. And just to give us some background, that's probably going to be a bit too low. So something like that, just to give us a background to work with, at least at the start. And then later on, we might decide what we might do with that. So here we go. Now, the first thing I want to do is when I'm developing, especially like a mobile game or something, I always want to make sure my game view is in the right aspect ratio. And so we'll go with a phone ratio of 9:16, so sort of vertical mode. And what I'll do, I haven't even saved the scene out yet, so we will save the scene as... How are we going to do this? Well, let's start with creating a ground and our bird. And to begin with, we'll just create some really simple assets. So we will go with a 3D cube for the ground. And we've got to orientate where our camera is here. So our camera is looking that way. And so let's grab our ground and pull it into the middle there. So I'll use the inspector to actually set it. So I haven't really decided whether we'll stick with 3D for now. We may come around and do like set the camera to perspective mode, but for now I'm curious to see what this game might look like in 3D. So let's just decide on a position for our world to be at. 20 looks pretty good, and so I'll need to scale the ground. And we'll just make it 50 in the X. Don't really care if it goes off screen. And then the Y, we will look like, well, we might do 50 as well. That will require us to drop it down a fair bit. Might put it there, and we will just increase it, say, 2 in the Y, in the Z, sorry. That seems fine. So it's just really going to act as something for our player to hit. We might bring that down even further, which means we'll drop our skybox down. Looks good so far. So immediately I want to start cleaning up my hierarchy. So we'll rename this to ground. And here's a tip for young players. If you want to keep your hierarchy clean, I create an empty game object, and then I create a bunch of labels using empty game objects. So I'll create one for the camera. And I'll just move it up there, and then I can duplicate that for lighting. We'll probably end up using very simple lighting for this game, but let's continue, and then we'll go environment. And if you're worried about like overhead for this sort of thing, again, it wouldn't matter for this game, but having a bunch of empty game objects in your hierarchy is not a big deal. And you can always delete them before you publish. So ground can go in the environment, and I'll create one more tag for player. And that keeps my hierarchy and my scene nice and neat. And so now we can go ahead and make the player, which I think we'll do a sphere for the player. And we'll call it player. And let's get the player into, whoops, roughly the right position now. Where did we put the ground again? All right, so we're keeping everything about 20 in the Z. So put the player 20 in the Z, and then we'll move them up. That looks a little small to me. So maybe we can increase the size of our player. Maybe 2? Yeah, we'll go with 2. Now, for now, it will suffice that we'll just create some materials just so we're not looking at some gray objects. And so it's a little more defined and easy to see. So we'll create some materials. We'll create material, and this one will just be for the player. And we'll create another material for the ground. So player, let's just go ahead and make it like red. We'll drop that onto the player there. And the ground, we'll make a like a brown color, I guess. That red's too close. Maybe green. So yeah, we might just go with a sort of pale brown. I'm looking at the original or the demo game, and it's sort of gone with like a pale, pasty color for the ground. I guess sandy looking color. So you know what? We might go with green. Green just stands out more. What we may come and replace all this later with some textures on some quads or something like that if we decide to go 2D, or if we're feeling like it, we could do like a 3D thing. Now, the idea that I'm going to go with is the player's not actually going to be able to move in the X and the Y. They're just going to move up and down. And I think the best way to maybe do that, so if we jump back to the Flappy Bird, is just applying a rigid body and letting physics take care of the dropping motion, and then we could use forces to try and push it up. I think that's as simple as it needs to get. There's obviously a lot of approaches you can do with how you control the player, but I think just letting gravity take care of the work here will be the simplest. And the other thing I'm just noticed is the player is a little off-center. So you can see the central line's there, and the player's just a little bit to the left. Not very noticeable, but just a little bit. So we will do that. So we'll offset the player a little bit to the left. I guess so you can see the tunnels coming a little bit more. So let's start with the player about -3, and we'll start them, let's say about 0. And what we're going to want to do is add a rigid body. And then, of course, we need to, so that will just fall. If I hit play, that'll fall and it'll just stay on the ground. But because we only want the player to move up and down, we will add some constraints to the rigid body. So we can freeze all the rotations, and we can freeze motion in the Z and motion in the X. Which can sometimes result in some wonky physics. But for this, again, super simple. And of course, now we get to the fun part of coding up our player controller. So we will create a folder for our scripts as usual. Another tip for young players is to put an underscore in front of key folders that you create. Especially if you use a lot of assets, sometimes your folder structure can get really wildly. And rather than having folders within folders within folders, I tend to just put the key ones I want to keep track of with an underscore. So that keeps them near the top. And of course, we will create our first script, which will be our player controller. Here's our script. And so what are we going to need? So this player controller is going to make use of a rigid body. So what we're going to just make sure is we're going to always have the required component, because we're going to get a reference to the rigid body, and we need to make sure that's always on the object. So we'll require component, and we want type of, and we will type in rigid body. And so now that will mandate that we have a rigid body. We know that needs to happen. It's not a very complex game, but good habits are worth keeping. So we will continue with that rigid body, and we'll call it player RB. So we will cache a reference to the rigid body, which we will get in the start. So player RB is equal to get component of type rigid body. And because we have that required component, it knows it's going to be there. Now that we have that, what we're going to do in the player controller is when the player presses a button, we will apply a force vertically. And so we're going to need a value for that force. So how big is that force going to be? So we'll create a private float called force. And we will serialize this field because we want to be able to change this in the inspector and play around with the actual value. And then the other thing what we need is to know what type of force we're going to use. And because I don't know off the top of my head what force is going to work, I'm going to create a serialized field. So something in the inspector that we can change. So private force mode, and we'll just call it force mode. So this will allow us to experiment with the different types of forces that we could apply to the rigid body. So then in update, we just want to check if the player has pressed a button. So for now, we could do something more complicated where we can define the button and have a bit more of a complex controller scheme, but I think I'll just use Unity's built-in system. So we will just go if input.getKeyDown, and we'll use spacebar for now. I think it's just key code space. So if that gets pressed down in that frame, then what do we want to do? Well, we want to add a force to our rigid body. So let's go player RB dot add force. Now we want the force to be directly up, so we can use the vector 3 dot up, and then we just want to multiply that by our value for force, and we will just use our force mode. I think that's all we need. It looks a little overly simple. What we might need actually is more gravity. Because if we have a look back at Flappy Bird, it falls pretty fast. So I have a feeling the gravity is not going to be enough. So let's test it out. So I'll save that. Go back over to Unity, and so let's just start with a normal force, which uses the mass of the rigid body. So tuck that away. So it uses the mass, and so we'll just go, let's go with 10. And let's hit play. And nothing's happening, so maybe the force value is too small, and you can see it's very small. So it takes a lot to push up the force, so what I might do is ignore the mass, and we might do like an impulse. Now I'm going to drop that down to 1, because impulse usually doesn't require that much. Well, maybe 10 was fine. That looks pretty good. Maybe 20. So that's probably too big. So it looks like we're honing in there. Now, I think that's actually fine. What's happening is what I suspected is that gravity is not enough. So what we're going to have to do is add our own gravity. What we could do is we could go into the project settings under physics and just increase the acceleration. I don't generally like doing that. So we will go and add an artificial force to the rigid body in the downwards direction. In case you're wondering, never just think increasing mass will increase gravity. It's a common misconception because mass doesn't change how fast something falls. Okay, so we got to add gravity. Now, what I could do is create a vector to hold the force and then add the forces together. But what I might not want to do is use the same force mode. So what I'll do is just simply add another additional force at the end of the update loop. So we will go serialize field, private, float, called gravity. And we will go down here, player.rb.add force. And now we will go vector3 down and we'll multiply it by gravity, which will be a value for gravity. Now, there are probably people screaming at me because I'm using physics in the update loop. For this game, I don't think it's going to matter, but as good practice, physics calculations should be done in fixed update. Ignore that part. Should be done in fixed update so you don't get any sort of weird movements. I don't think it will matter, but let's continue with that. So we've got our value for gravity, and we're adding that at the end of every fixed frame. So with that, I think we can give it another go. And so now we've got a value for gravity. Now I don't need it to be negative because I'm using the down force, so it can just be a value. Let's start with 10. Now, because I didn't define a force mode, it's just going to use acceleration. In fact, no, it won't. It will use the standard force. So I will change the force mode to acceleration. And I don't think it has a tooltip. So this is adding a continuous acceleration to the rigid body, ignoring its mass. So let's have a look at that. So it falls a little faster. Now, I didn't save the changes from before. I think we're on impulse. So not too bad. Let's try velocity change. I think we had 15 before. Gravity still seems a bit low. Doesn't feel quite right. What I might do is really crank up this force. There we go. So that feels a bit better. Now, I'm realizing I goofed, and what I'll do, firstly, is we'll halve that to 15 again, and I'll just copy this component, and I'll stop, and we will hit paste values, just so that remains the same. Now, back here, when I changed this from fixed update, or from update to fixed update, I did that because we were using forces, and my brain just went, oh, you should do that on the physics frame. But the problem is we're also getting input, and so we should do that every frame. And so that's why we've got this sort of latency in the input. So we're going to have to stick with update. There's a whole lot of solutions to this problem, like mostly using coroutines, I think is the best way to go about it. But again, because I don't think it's going to matter, I think we can just stick with getting the input and using that. So let's try that again. Now my input's actually working. Gravity is now definitely too high. So let's play around with some of these settings. That feels pretty good. So it's definitely falling. Force up is a little bit slow. That's starting to feel pretty good. So let's increase that. And what I might actually do is increase the drag a little bit. Let's try increasing drag. So this will just sort of reduce the impact of my forces. That feels a lot better. There we go. That feels pretty good. So just sort of playing around with these values. There's no right answer here. Maybe you want something more wonky. I think that's going to be correct. It's a good starting place. So maybe I can drop that drag down even more. That's pretty good. So I'm going to copy that component, and we'll remember the drag is 1.5. So we will paste those values and crank that drag back up. Now, the first problem I'm noticing is that the player can go infinitely high. So now we need to just add a check to ensure that the player can't go any higher. Now, there's a couple ways we could do this. We could put a collider up. In fact, I'm tempted to do that. I know the player is not going to move left or right or down, so it's really just stopping them from moving up. We could do a check. Let's actually have a look at the original for a sec. So what happens? Yeah, well, it looks like there is no limit on this game. Well, that's not good enough for me. So we're going to add a limiter. So, and we'll put an artificial boundary on how high they can go. So let's jump back to our player controller script, and we'll add another field, another private float. This time for max height threshold, and so if I go and so what this kind of means is that if this one returns false, it won't review the second condition. So it won't, if they don't push down, then it won't check if it's at the height or past the max threshold height. So if transform, so we'll just get a reference to the transform position dot y is, which way do we want it? So if it's less than the max threshold height, then we can apply the force. Otherwise, do not apply the force. So what is that height going to be? I'm still playing. So that height is about, I mean, this will depend on the camera. So we'll have to bear that in mind, but for now it will work. Let's say we don't want to apply a force after about 18. And so I can go off the screen, so maybe we'll drop that down to 16. So you can still go off the screen, but you can't go that far. So let's set it to 15 maybe. If you go crazy with it, you can absolutely go too fast. But if you're at the top, you're not going to go too far. We'll leave it at that. Okay, so now that we've got our player working, what do I want to do now? We need to create the tunnels, I guess, for the player to go through. And so we'll do that again just by adding. Well, first thing we'll need is a object pool, because we'll be spawning a lot of them continuously. This game's simple enough, it's probably overkill, but let's go ahead and do it. So we'll create a empty game object to hold this, and we'll call this tunnel spawner. Spawner. And we'll go to our scripts folder and we'll create a new script and we'll call it object pool. Now there's a lot of different variations on an object pool. We will do a very simple one. So that will take a prefab. And so what this object pool will do is instead of constantly creating new game objects, it will store several game objects and just set them active or inactive. So that way we can sort of improve performance. That's the idea of it. So the first thing we need is a prefab. The other thing we're going to want is a private queue of type game object, and we'll call this the pool. We can get rid of, well, we can't get rid of start actually, because we need to create the pool. So we need to create a reference to the pool. So we'll go new game object pool. So from the beginning, we will create the pool. But we don't need update, but we need a couple methods. The first is, so a couple of access methods. So public game object. So a public method that will return a game object, and we'll call it get from pool. And so this will return an object from the pool, and we'll also need a public method, void, because it won't return anything. It will just add to pool. So it will, in fact, actually we'll call it return to pool. But this one won't return anything, but it will need to take in a game object, and we'll just call it object. Fantastic. So, and then we'll have a private method called grow pool. And essentially what this will do is it will add objects to the pool as we need them. So in case the pool runs dry, we will call this method. So we'll write this one first. So for I, and let's just say 10. So for 10 times, we will instantiate a game object. And we'll go var new object. And it will be equal to instantiate. So we'll call instantiate on our prefab. So we'll create a new instance. And that will, I don't really care where it gets spawned at this stage. What we want to do is just set it to inactive. So set active false, and then we want to add to the queue. So I could have used a list for the pool, but a queue is a little better because it allows me to do this, which is in queue. And so we'll just add it to the back of the queue. Of course, it needs to take the object. And so that will grow our pool. So when this method gets called, we'll add 10 objects to the pool. So it shouldn't be called too often. And then at the start, when we create our pool, we will call grow pool. And so when we get from pool, we just want to return pool.dequeue. And so what that does is it just removes the next object in the queue, and it will return it. So we'll remove it from the queue, and it'll be the next one up. So very useful. So it's a little more efficient than getting the first object in a list and then removing the first object in the list. It does it all in one go. Okay, and then of course return to pool. When we get the object, we want to firstly set it active is false. And we want to go pool dot enqueue to be object. Now, this just did remind me, when we return the pool, it will return the object as inactive, which I don't necessarily want. It's slightly unintuitive. If I was making a more complicated pool, we may add some more functions like get from pool inactive or something like that. But what I might do is we'll go next object equals pool dot dequeue, and we'll go next object dot set active is false, and we will go return next object. Now, it probably creates unnecessary garbage, but I might change this from start to awake. Just because I definitely want that ready before we start calling on it. And I think that's fine for that. So let's go add that to our spawner. And we will reset. Not that that's really necessary. And we'll add our object pool. But what will our tunnel be? Well, I think for now, we will just go with a 3D object of a cube. And let's create a material for it. Just so it is a little more visible. What color? So I guess blue for the tunnel. I mean, Mario tells me tunnels are green, but that would mean we'd have to change our ground, which I think we will do. So we'll make it like a bright green. So I'll just change that ground to something a little more bland. And just so our tunnel pops a little more. Then we need to make the tunnel a bit wider and a bit longer. So I think that will work for now. So we need, of course, a folder to hold our prefabs. And so we'll drop our tunnel in there. And while we're at it, let's just add the player. So let us create now the actual script for handling spawning. So we'll create new C# script called spawner. Okay, so we have our spawner script. So the first thing we're going to need is a reference to our object pool. There's a couple ways we can do this. I think I'm just going to use the inspector. Actually, as a matter of fact, I'm just going to make sure the object pool is on the same object as the spawner. So once again, we'll go require component, type of object pool, and we will just get a reference to that in start object pool called pool. And so that's why I changed the previous method to awake, just so I knew the pool was ready to go before we even not you object pool, you fool. Get component of type object pool, please. So I know the pool is going to be ready when we call start. Okay, so now what we want to try and figure out, so we get a reference to our pool, so we can get a reference to our tunnel objects, and now we got to decide where to spawn them and how often. So the how often part is pretty easy. What we can do is just create a field in the inspector that we can vary. So we'll go private float, and we will go with spawn rate, and I'll just leave a comment to help with this, and we'll just say time between spawns in seconds. Just because spawn rate can be a bit ambiguous of meaning, so what we'll do there. Now, what I'm going to actually do is use a coroutine to keep spawning objects. So we won't use update. And so what we'll do is we'll create a private coroutine. So of type IEnumerator, not enumerable, enumerator. It's not going to have a type. We don't need a type. And we'll just call it spawn async. Now, this is just a habit of mine, is when I'm writing a coroutine, I always use the term async, and that's really just so that when I know to call it, or when a script calls it, I know this is a coroutine, and so I can't just call it like a normal method. And so we'll call spawn async, and I'm going to do something that's probably considered a little naughty, and I'm going to create a while loop that never finishes. So as it is, it will crash, but what I'll do is I'll make sure we return, wait for new wait 4 seconds. So yield return, and the time we're going to wait for is the spawn rate. So having a while loop that doesn't ever finish is probably not a great idea. But because I'm doing this yield return new, it's not going to cause Unity to crash. And so that is good. And so what I'll do in start is I will start the coroutine. So we will go start coroutine, and we will call spawn async. So from the very beginning, we will start calling this coroutine, and in here, we will go spawn tunnels. And in fact, we'll do it the other way. We'll go spawn the tunnels after we wait. So it'll give a little bit of time before this actually starts going. So in start, we'll start this coroutine, and then this will keep going forever. We might come up with a break method or a way to stop this, but for now, this will do just fine. So now we've just got to figure out how to spawn it. So we will create a couple of references here. So we'll go with var, we'll go top tunnel, and it's going to be equal to pool.getFromPool. And I also want the bottom tunnel is equal to pool.getFromPool. Now we've just got to decide on where to position these objects. So let's go back to Flappy Bird for just a moment, and what we see is if the gap's at the top, then the tunnel extends. And so the way I'm thinking about this is rather than defining where the tunnel should be, I'm going to think about in terms of where is the gap going to be, and then how far from the gap is the tunnel going to be positioned. So let's think about in terms of where the gap is going to be. And so what I'm going to do is create a serialized field. So a vector2, and we want to go gap range. So I'm using a vector2 so I can define a minimum and a maximum for the range. It's just a little trick that I do. You could define two values here instead. If you were very clever with your inspector, you could write a custom inspector field for this. But I just use a vector2, and I know that X component is going to be the minimum and Y is going to be the maximum. And so that'll define where the gap can spawn. And then we need another value to hold the gap size. So how big is the gap going to be? Okay, so if we jump back into Unity, let's think about this for a moment. Okay, so in order for this to work, I might keep the scale of the tunnel fixed. So if I keep it at 40, then it's always going, no matter where the gap's going to be, you'll never see the edge of the tunnel. So I'm going to keep the scale of the tunnel at 40. And so then the gap position, if I want it to be at 10, it will be set at the gap position minus the gap size. So let's say I want the gap size to be 2, and then minus half the scale. It will always be in the correct position. So that's how we want to write the transform. So let's try and write that into the position. So we will go for the bottom tunnel, the position, the transform dot position is going to be equal to a new vector3. Now what I probably also want is the position in the X. So we'll go serialize field private float x position, and so that will be the start position. So we can define that to be off screen wherever we want. Then the y is going to be equal to our gap position. So let's get our gap position. So var gap position is going to be equal to, and we want mathf.random. Oh, do I? Oh, it's just random. Has its own class. So random.range. And what we'll do is we'll go gap range dot x and gap range dot y. I said dot y, not comma y. Excellent. So basically this is returning a random value between the defined minimum of the gap range and the defined maximum. And so what we will do is we'll go gap position. And again, for the bottom tunnel, we want to go minus the gap size. And then we want to go minus transform dot scale dot y. And of course, it's not of this object. It's going to be of the bottom tunnel dot transform dot local scale dot y. We could cache this in the object pool as a variable, but I think I'll just leave it for now. And of course, the z, we will create another field, private float z position, and we'll just set that just so we can change it later if we want to. Okay, so that should spawn the bottom tunnel. So we want to actually repeat the same thing for the top tunnel. But naturally, instead of adding or subtracting the gap size, we want to add it and then add the scale. I think that'll work. So spawn tunnel, so we spawn the top and the bottom. And then, of course, we go back to the start of the loop and we wait. I think that's going to be fine. Let's give it a go. What's the worst that could happen? So we'll go to tunnel spawner and we will go to spawner. I probably should have called it something other than spawner. And we'll go spawn rate, let's say every 3 seconds. And we'll say the gap range. Let's have a look at our player here. How big do we want the gap? Let's say we want the gap to be about 5. Sorry, gap size, we'll say about 5. And so the gap range, we don't want the gap to be any lower than, say, about -4. So anything below that will be sort of going into the ground and they'll make it impossible. So we'll say, like, let's go -8 and 16. So between -8 and 16. So the gap could form anywhere between those heights. Gap size is 5. X position, let's grab our tunnel. And we'll say 25 sounds good. And the Z position is, well, just the same as the player at this point. So we'll just set that to 20. And I think that will spawn our objects. And of course, let's go to our prefabs and we'll add our tunnel to the object pool. Now, some of you may be realizing there's a problem with this and that nothing's going to happen if we start spawning the tunnels. So what we need to do is add a script that will make the tunnels move left to right. And so we'll do that very simply just by updating the transform. So let's go create C# script and we'll call it tunnel controller. So we'll start with this and we will go with a serialized field. We'll go private float called speed. We don't need start. And in fact, we will just do it in update, and we'll go transform dot position. It's going to be equal plus equals, and we'll go new. So we'll go vector 3 left, and so that is going to be a vector of magnitude 1 to the left, and we'll multiply by our speed. And of course, we're doing this in the update loop, and we're modifying the transform directly, so we will want to make this frame dependent. So we'll go speed times delta time, and Rider is telling me that my multiplication is inefficient, so we will flip that around. And I think that's all we need. So let's test that part out. So what I'll do is I'll just turn off our tunnel spawner for a second. Add this to our tunnel. So we'll go tunnel controller, and let's just get our speed value right. So let's set it to 1. You see it's moving off very slowly, so we probably want something more like 4. Let's try that again at 4. Maybe even faster. Let's go 5. And I almost kind of wanted to shrink them a little bit. I think they're a bit too fat. So let's go to 4. And what I'm going to do is extend that ground a little bit in the Z, or make it really thin. Just don't like the way the tunnel is kind of clipping through it. So let's maybe do something like that. And I don't know why the ground is not at 20. So we'll do 5. And that looks a lot better. So let's have a quick test of that. I think that'll work. So let's apply that to our prefab. And we will just turn off that tunnel and turn on our spawner. And let's see this in action. So the object pool worked perfectly. So we can see in the inspector all the tunnels got spawned. The actual... they didn't get activated. Didn't we deal with that in the object pool? Set active... that was silly, wasn't it? Set active to true, not false. How many people were waiting for that? I wonder. Okay. Still didn't work. Oh, there it is. So it just took a few seconds. That gap range is huge. So let's adjust that. Or gap size. Let's go 1 for the gap size. Unless there's something wrong with our calculation. Something very wrong with our calculation. Oh, I realized what I did. All right, so it's, if we go back to the spawner, it is half of the scale, not the full scale. So that's going to be the problem. Let's try that now. All right, that's much better. And in fact, our gap is tiny. So I'm just going to ignore the player for a moment, and we'll go to our tunnel spawner, and we will increase the gap size. Okay, so that also presents us with another problem. So our object pool is not working quite as we thought. So there's a part that I forgot, so let's stop that. Let's add the gap size to 5, because that part's correct. And let's go back to our object pool. Now, we grew the pool at the beginning, but what we failed to do is when we get from the pool to check if the pool has anything in it. So that was a big mistake. So let's go if pool.count is less than or equal to 1, we will call grow pool. Actually, let's just make it 0. So test again. I think the timing at the start's a bit big, and so we can see the gap is spawning too high. So we'll drop that down. So that looks good so far. And we can see there's not a lot of variance in the gap height. Okay, so far I'm pretty happy with this. One element we could look at is whether or not we want this to be completely random or whether we want to add some difficulty curves to it and make it intentionally go up or down. But I think this will be fine for now. Now, the next problem that we have is this. So you can see all of the tunnels keep just getting spawned. So we need a way to despawn the tunnels. So let us add a trigger. So what we'll do is we'll add a 3D plane, and we'll just rotate that so that it faces the right way. So 0, 0, and 0. And then we want to rotate that. Which way do we want to rotate it? We want to rotate the Z, so we'll rotate that into the -90, and we will go 0. And we will go with a trigger. So we'll set the collider to a trigger, and we'll make it huge. And so we'll position this off screen like so. So that way all our tunnels will collide into that, and it will trigger this. So we don't need the mesh renderer on it. Now what we do need is a rigid body, because we want to use trigger events, but in order for a trigger to be called, it needs to have a rigid body on one of the objects. We could add a rigid body to every tunnel, but since they're not doing anything, I feel like that would be unnecessary amount of rigid bodies in the scene. So what we can do is add the rigid body to the trigger and just freeze everything. Turn off gravity like so, and we'll rename this to tunnel trigger. That'll do. And we'll put that in environment, and we will add a script, and we'll call it tunnel collector. And we'll add that script to our tunnel trigger. Actually, I should rename these so they're all the same. Tunnel collector, okay. And so let's open up that script, and we won't need start or update. What we do need is on trigger enter. And the other thing we need is a reference to the object pool. Now, because it's not going to be on the same object, we need to add it in some way, and I think the easiest way at this stage will just be to do it in the inspector. So object pool called pool, and we'll go on trigger enter. So, and we'll go other. So we need to test if it's the tunnel, although we can at this stage assume it is going to be the tunnel. We'll do it properly. We'll go if other dot compare tag is equal to tunnel, and Ryder's going to get upset because I haven't made that yet. So if it is the tunnel, what we'll do is we'll go pool dot return to pool, and we'll pass in other dot game object, and that's all we need. So let's go back to our tunnel prefab, and we'll open up the proper prefab, and we'll go add tag, and we'll call it tunnel. And here's something I don't like about Unity is when you create the tag, it doesn't automatically add it to the object that you were just trying to add it to. So we'll do that. We'll go tunnel, And I think that's it. So fingers crossed, if we hit play, of course the settings I didn't apply them, so we'll have to go back and adjust them. But so far so good. So there's definitely something wrong here because I'm actually doing pretty well. So you can tell something is definitely wrong. And we can see our tunnel collector is not working. And we got an error, not set to an instance of an object, of course. We did not add the pool to the tunnel collector. And while we're at it, let's go to the tunnel spawner. And I think we had this at like -5, 15. And we'll speed that up a bit. Oh, to speed it up, I probably should have gone down the other way. And you can see our tunnel collector is now stopping the tunnels from infinitely spawning. And you see our object pool is working. You can see it's creating only the amount of tunnels it needs, and then it's activating and deactivating them as needed. So that part is working quite lovely. And I think we'll take a break from here, and then next week we'll have a look at well, killing the player and adding a scoring system. So check in next week for that. For now, thanks for watching.